Alright, it's Mr. Gilman. Today we're going to graph linear inequalities in two variables. So, it's going to be a good day. Before we get started, let's talk about what makes a solution to an equation. The directions say tell whether the given ordered pair is a solution of the equation 5x minus 2y is less than or equal to 6. So what we're going to do is this. We're going to take my x and my y, and remember, always our coordinates are in the form x comma y. And we're going to plug them in. If it makes a true statement, then this point would be a solution to the inequality. We're just going to plug in 0 for x, minus 2 times negative 4 for y. Please make sure when you plug in negatives, you plug them in with parentheses. 0 plus 8 is less than or equal to 6. 8 is less than or equal to 6. This is not a true statement, so no, that is not a solution to this inequality. Okay. What about the point 0, 2? We're using the same equation, same directions. We just need to know if it's a solution or not. So we're going to say this is x and this is y. Plug in some numbers. 0 minus 4 is less than or equal to 6. So negative 4 is less than or equal to 6. This is true. So yes, this would be a solution to this inequality. Let's do a couple more here. Same idea. You got another coordinate. I need to know, is it a solution? So we're going to plug them in. X and y. 5 times negative 3 minus 2 times 8 less than or equal to 6. Negative 15 minus 16 is less than or equal to 6. So negative 31 is less than or equal to 6. That is true. So yes, that will be a solution to the inequality. Negative 15 minus, yep, that would be a solution. And one more for good measure, so we all know what's going on. The point negative 1, negative 7. Is that a solution to this equation? Once again, it is only a solution if it makes a true statement at the end. There's x and y. 5 times negative 1 minus 2 times negative 7 is less than or equal to 6. Negative 5 plus 14 less than or equal to 6. This is plus 14. 9 is less than or equal to 6. So I know that this is not a solution because 9 really is not less than or equal to 6. Okay, so we're going to use this today when we're graphing. We need to understand what does and does not make a solution to the equation. Let's just remember a few things. Okay, today when we're graphing, we're going to have inequalities. Okay, so we're not going to have y equals mx plus b. What we might have, y is less than mx plus b, or y is greater than mx plus b, or anything like that. Okay, just remember, on a regular line, the only coordinates that are solutions to the line are points on the line. Okay, inequalities have infinitely many solutions, because if I say x is less than 2, there's infinitely many numbers that are less than 2. If I say x is greater than or equal to 5, there's infinitely many numbers bigger than or equal to 5. Okay? Just to remind ourselves, y equals mx plus b, that's the equation of the line. You start at the y-intercept, the b value, on your y-axis, and then you move your slope, rise over run. That's very important for today. Okay. To graph a linear inequality, we're going to use these steps. Step 1, you're going to just graph it like it says equals. So you need to set it equal to y, find the intercept, put it on there, use the slope, move up and over. Okay. Step 2, if your sign is a less than or greater than, you're going to make the line dashed. If your line is a less than or equal to or greater than or equal to, you're going to make it a solid line because equation or the solutions are included on the line. Step 3, we're going to test a point not on the boundary line. So just like what we just practiced, we're going to put a point in on one side or the other of the line and see if it works. If that's the side that works, you shade that side. If that's the side that does not work, you shade the other side. So hopefully this will make a little more sense as we get into one here. We're going to start with a simple example here. Okay, we have the inequality y is less than or equal to 1/2 x minus 1. Now, from our previous knowledge of graphing lines, I like it in the form y equals mx plus b. And for now, it is in y equals mx plus b form. Here's y equals mx plus b. So my b value, my y-intercept, is -1. I'm going to start at -1. Remember, our axes are x and y. I'm going to start at -1 on the y-axis because that is our y-intercept. From there, I'm going to use my slope, rise over run. I'm going to rise 1, run 2, and put my second point. Now I'm going to graph it just as if it's a line. Put it right there on there. Actually, I'm going to continue my line all the way through the graph for these today. As close as you can get it there. All right. And now I have my inequality on there. I need to check if this is a less than or equal to or greater than or equal to. I can leave the line solid because points on the line are okay to have it's equal to. Okay. The final step I need to do is check to see which side of the inequality to shade my graph in on. I like to use the point 0, 0, or points that are very simple to plug in. 0, 0 is above the graph. The coordinate 0, 0 is above the graph, and you can pick any coordinate you want. I recommend you pick an easy coordinate. If this is a solution to the graph, that's the side I'm going to shade. If it's not a solution to the equation, I'm going to shade the bottom half. So y is less than or equal to 1/2 x minus 1. I need to know, is 0 less than or equal to 1/2 times 0 minus 1? 0 is less than or equal to 0 minus 1. 0 is less than or equal to -1. That is not true. No, it's not a solution. So this coordinate right here is not a solution. So nothing, I'm going to generalize, nothing on the top is a solution. Therefore, everything on the bottom must be a solution. So you need to shade in anything below your graph. Okay, these all represent solutions, and I'll show you. Okay, the point 0, -2 should be a solution because we shaded in the bottom half. Let's see if it is. Let's plug it into our equation. -2 equals 1/2 times 0 minus 1. Actually, it's less than or equal to. -2 is less than or equal to 0 minus 1. -2 is less than or equal to -1. Yes, that's true. So as you can see, it does work out. Okay, any point down here will make a true solution to my equation. Take a look at another one here. Like I said before, we want it in y equals mx plus b form. And it appears that it is that way right now. So let's go ahead and graph our equation just like it was an equality, just like how we know how to do it. So I'm going to start at -2. I'm going to say my slope is 2, which is rise over run, keep in mind. So you can put that over 1 if you'd like. So we're going to rise 2 and run 1 and put our first point. Okay, now that I have 2 points, I can connect my dots. And like I said, I'm going to go ahead and continue it all the way through my coordinate plane here for today. And now there's 2 things that are different about inequalities that we didn't used to do. The first thing we need to check for is whether our line should be solid or dashed. This time it's just a less than sign. So kind of like on a number line when you use open dots, on a graph you're going to use a dotted line. So let's just make a little dotted line here. Okay, now my line is dashed. Finally, I know that either one side of my graph is going to be a solution or the other side is going to be solutions. So once again, I notice the point 0, 0 is on the left-hand side of my graph. So I'm going to go ahead and plug in the point 0, 0 just to see if that's the side that works. Is 0 less than 2x minus 2, or 0 less than 2 times 0 minus 2? I'm going to say no, 0 is not less than -2. And if this is the side that I got 0, 0 from on the top, this side, I'm going to say if that's not a solution, then this side must be the solutions. I'm going to go ahead and shade in the bottom. I know to shade the bottom half because 0, 0 is here and it doesn't work. That means the top half does not work. So let's do another one. Y is greater than -2. Once again, I'm plotting it just like an equality. So I'm going to look at my y-intercept. It's not there, so I'm going to start at the origin. My slope is -2 over 1. I'm going to rise -2 and run 1, put my second point, and continue my line all the way through my graph today. Alright, so far I have it graphed. We're in good shape. However, what's different about an inequality than an equality is I need to check to see, is this a dotted line or a thick line? Right off the bat, I notice it should be a dotted line because it's a less than or a greater than sign. I'm going to go ahead and make a dashed line. The next thing I need to do for an inequality is see which coordinates are going to be solutions. So because 0, 0 goes through the line, I can't use 0, 0. So I'm going to pick the coordinate 1, 1. That's an easy coordinate to plug in to my equation here. I'm going to pick the coordinate 1, 1. And this is going to test if the right side is a solution or not. Is 1 greater than -2 times 1? 1 is greater than -2. Yes, so I know I got my point from this side, and it is a solution, so I'm going to shade this side. Okay, and that's the solution of that equation as a graph. But then there might be some problems like this, where it's going to be a little trickier to graph. Remember, these are linear inequalities, so we want them in the form y equals mx plus b. The problem here is remember, this represents our equal sign. We don't have y by itself. So what I can do is I can add 2x to both sides. And now I can say y is greater than 2x plus 4. And now it looks like my linear equation, where b is the y-intercept, m is the slope. So I'm going to start at my b value, positive 4. I'm going to use my slope, rise over run, up 2 over 1, up 2 over 1. They're both in the positive direction. So I have my 2 points, and now I'm going to go ahead and make my graph. Okay. Now the things that are different about an inequality are whether it's a dashed or solid line, and which side is shaded or not. This sign tells me that I need a dotted line. So I'm going to go ahead and put my dotted line in there, because points on the line cannot be equal to it. The next thing I need to do is find out which side I need to shade in. So 0, 0 this time just happens to be on the bottom, so I'm going to test for the bottom half. I'm going to say 0 is greater than 2 times 0 plus 4. And where I got this was I plugged it into this equation here. 0 is greater than 0 plus 4. 0 is greater than 4. That's not true. Now, this time 0, 0 just happened to be on the bottom half. It's not a solution, so nothing on the bottom half will be a solution. Therefore, the top half will be solutions. So anything up here, you need to shade in the top half of your graph. Alright. Once again, we have a trickier equation to graph this time. Just like a linear equation, we want it to be y equals mx plus b. So what we need to do is we need to solve for y. I'll begin by subtracting 5x from both sides. Negative 2y is greater than or equal to negative 5x minus 4. Divide both sides by negative 2. And be careful, everybody, because this is where you're going to make a mistake. If you divide by a negative or multiply by a negative in an inequality, you have to change the sign. So this is now a less than or equal to sign. 5 has x. Make sure you also put this negative 2 into both parts, plus 2. Okay, it goes into both parts. So this is actually our inequality. As you can see, it changed direction because we divided by a negative, and I had to make sure to put the 2 into both parts. So I'm going to graph it now. Once again, I'm starting at my y-intercept, positive 2. I'm going to use this, my slope. Okay, it's a positive slope now because the negative divided by a negative is a positive 5 halves. So I'm going to rise 5 and run positive 2. I'm going to connect my points, make my line. Okay, But keep in mind, we're using an inequality this time. That's how we know to shade. I need to check to see if it's going to be a solid or a dotted line, because it's okay for it to be equal to. I know I can make a solid line. But now the last part is I need to figure out which side to shade. Once again, I'm going to plug in 0, 0 just because it's just easy coordinates to put in. I can plug it in here. I can plug it in here, whatever you prefer. And I just need to see if it's a solution, the side with 0, 0 on it is the side I shade. If it's not a solution, the side that doesn't have 0, 0 is the side that I shade. So I'm just going to plug it in down here. 0 is less than or equal to 0 plus 2. Or 0 is less than or equal to 2. That's a true statement. That means 0, 0 is a solution. And 0, 0 is right here, so I'm going to shade everything on this side of the inequality. Now let's get into some simpler graphs here. Okay, I just want to remind you that the equation y equals 2 would be a horizontal line. So these won't take long at all. We know that y is less than 2. That should be a horizontal line at 2. I'm going to go ahead and put that one on there. But now it's different because now I need to know, is it going to be solid or dotted? So what I'm going to do is I'm going to have to dot it. It's a less than sign, and less than or greater than always are dotted lines because solutions on the line will make things equal. That's not okay. There's my dotted line. Finally, if I plug in the point 0, 0, it's just one that I like to do, 0, 0, into my equation, I get 0 in for y, there's nowhere to plug in x, 0 is less than 2, so I can shade on the bottom because the bottom is a solution. Let's look at 0, or y is less than or equal to negative 3. The graph of this would be right here. This is my x and y axis. Okay. I need to determine, is it a solid line or a dotted line? It's a less than or equal to, so I know I can make a solid line. And now the last thing I need to do is see which side to shade. So I'm going to plug in 0, 0. This time it just so happens that it's on the top. Is 0 less than or equal to negative 3? No. 0, 0 was right here in the middle, and that's not a solution, so I need to go to the bottom of the graph and shade the bottom again. Y is greater than 1. My graph look like this guy on 1. X and Y axis. Okay. But I notice that it's a less than sign, so I need to be a dashed line. Finally, I need to see which side works. The point 0, 0, right in the middle. I'm going to plug in 0 for y. Is 0 greater than 1? I'm going to say no, it's not. If this is not a solution, I need to shade the top half. Okay. One more for good measure. If y equals a number is a horizontal line, then x equals a number is a vertical line. So I'm going to graph x equals 2. Right there. Okay. I know that I need a solid line because of the greater than or equal to. And the last thing I need to do is just figure out which side to shade. So if I plug in 0, 0, 0 is greater than or equal to 2. That's not true. 0, 0 is the coordinate right in the middle. That's not a solution. Therefore, I need to shade in the right-hand side. X is less than negative 1. Remember, x equals are always vertical lines. Right there. I need to check, is it a solid line or a dashed line? It's a less than sign, so I know I need a dashed line. Now I need to figure out which side to shade. Use the point 0, 0 since it's not on the graph. 0 is less than negative 1. That's not true. So what I can do is I can plug in. If this point is not true, I know this side is the side I need to shade. What about x is less than or equal to 3? Once again, it's a vertical line at 3. Is it a solid line or a dashed line? Because there's an equal sign, it's going to be solid. And I need to plug in a point. 0, 0 is a good point to plug in. It's not on the graph. 0 is less than or equal to 3. That's true. Yes, so if this is true, all points on this side must be true. So go ahead and shade that guy in.